Now, when the sum of the degrees of the differential parameters are of the same, then they are of the same dimension, then we say that the differential equation is what is an homogeneous differential equation. So the differential parameters can be x, y having a dimension of 1, that is x raised to power 1, y raised to power 1. So that's the dimension. The dimension of that is 1. X raised to power n, y raised to power n, the dimension is n. But a differential coefficient, that is the y dx, the dimension is 0, while the second derivative of the differential coefficient is minus 1. That is, when you have the squared y over the x squared, we have 0 minus 1. 0 minus 1, which still remains minus 1. Then the differential coefficient raised to the power of n is 0 minus n minus 1, which is still the same thing as minus n minus 1. So in this example, we'll verify whether the DE is homogeneous or not. But as you can see clearly that when we apply the dimension of x and y will give us the dimension of the squared y, the x squared will give us minus 1. So 2 minus 1 is giving us 1. So also the dimension for x is 1. The dimension of the y dx is 0. 1 plus 0, that's 1. Also the last part, dimension of 3y is 1. So you see clearly that the three terms in the differential equation have the same dimension. So we can go ahead and solve, since it is an homogeneous equation. So we say let x equals to e raised to power t, such that when we differentiate the x with respect to t, we have e raised to power t. Then when we take the t up and bring the s down, we have e raised to power minus t. Now, using product rule, the y dx is the same thing as the t over the x times the y over the t. You can see the t can cancel out. We are left with the y dx. But what is the t dx? The t dx is already giving us e raised to power minus t, and we multiply it with what? Our dy dt. Therefore, the y dx equals to that. Alright, so since our dy dx is now e raised to power minus t dy dt, therefore the squared y dx squared as well will have it as d dx times the y dx. But what's d dx? You can see we deduce our d dx to e raised to power minus t d dt. Then our dy dx is already given as e raised to power minus t dy dt. So when we multiply, we bring out e raised to power minus t and we use product rule on e raised to power minus t dy dt, then we arrive at our final answer to be that. So we have e raised to power minus t, the squared y dt squared minus the y dt. Now when we substitute, we have it to be the expression below. But please take note, kindly change that there is a slight error, and after substituting, we have y e raised to power t e raised to power minus t, the squared y dt squared minus, it is meant to be the y dt, not the y dx, so kindly change that. Then we have all our expression given as that. Now if we are to simplify, on simplifying, we have our we brought out our y to be the squared y over the t squared minus 4y. Where is the 4 minus 4y coming from? We bring in the 3y e raised to power minus t. Then we have it to be minus y minus 3, that's minus 4. So we have our expression to be that. So we let our p to be equals to the y dt, such that the p dt is the squared y over dt squared. But don't forget, the squared y dt squared can still be written as d dt times the y dt. But d dt is already given as p, so we have it to be p dy dt. So we substitute back again. We have our final answer to be, we have our next expression to be yp the y dt minus 4yp plus p squared equals to 0. So when we divide through by yp, we have the y dt plus p over y equals to 4. So we look for our integrating factor. Our integrating factor is e raised to power integral of 1 over y, which is still the same thing as y. Then we use y to multiply through with our integrating with the initial expression. So we have it like as that. So we have it to be y dy dt plus p equals to 4y. Then, but when we integrate both sides, we're using product rule. We have um, everything to be d dt p of y. Then we integrate both sides. So the integral sign and derivative sign cancels out automatically. Then we are left with py equals to 2y squared plus c or k1. But don't forget, what's our p? Our p is given as the y dt. Then we have the y dt times y equals to 2y squared plus 2k1. But going back up, we have the y dt times y equals to 2y squared plus 2ky. Then we use variable separable to separate the variables. Then we have integral of the t. Then when we integrate the right hand side, we have t to be 1 over 4 ln y squared plus k1 plus what plus k2, because we are having another constant. But t is equals to 1 over 4. Then we do the simplification. Then we take the 1 over 4 to the other side since we have a logarithm. Then we have ln y squared plus k1 times k2 all raised to power 1 over 4. Then we simplify further. We have y squared plus k1 all raised to power 1 over 4 equals to e raised to power t. And e raised to power t, from our normal expression from the given question, we have e raised to power t to be equals to x. So we have our final answer to be s raised to power 4 y squared plus k1 times what? K2. Thank you.